Hi, my name is Marissa Padilla, and I'm going to teach you how to do problem 43 on page 345 in chapter 6, section 2. It is about binomial probability distribution. Number 43 states, according to the flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. Suppose 100 flights are randomly selected. The first thing you want to do is distinguish the sample size, which is 100 flights. So n equals 100. The second thing you want to distinguish is the probability, which is 80%. So you've conformed that into a decimal, so it's p equals 0.80. Okay. Part A says, compute the mean and the standard deviation of the random variable x. The number of on-time flights in the 100 trials are randomly selected. So you find the mean of x by going u of x equals n times p. So n times p equals 100 times 80, 0.80, I'm sorry, which equals 80. To compute your standard deviation of x, you go standard deviation equals the square root of n times p 1 minus p. So you just plug in everything. So it's n is 100 times 0.80 and then 1 minus 0.80. So the first thing is 100 times 0.80 is the same thing right here, is 80 times 1 minus 0.80 equals 0.20. And you find the square root of that. You can plug it into your calculator by doing the second, and then you go to x squared, which is a square root, then 80 parentheses times 0.20 equals, I did it wrong. 80 times 0.20 equals 16. Now you just have to find the square root of 16. The easy way to find the square root is you go to your calculator, you go press second square root and plug in 16. Which is just like this, and you press enter, and that's your answer, which is 4. So your final thing is u of x equals 80, and your standard deviation of x equals 4. And in green, these are your formulas that you need to use for every problem to find your standard deviation and your mean of x. Part B asks you to interpret the mean. The mean is basically the average of times. So, as we figured out in part A, this mean equals 80. So, out of 100 flights, 80 of them would be on time. Period. Part C asks, would it be unusual to observe 75 on-time flights in a random sample of 100? So, as I stated before, in 6.2, we're working on binomial probability distributions. So, the first thing you need to do is figure out the formula for a binomial PDF, which is binomial P. You want to use P DF, which equals N times the comma probability comma X. This is a formula that you plug into your calculator. First of all, you want to figure out what N is. From the first problem we stated, N equals 100. We also found out that P equals 0.8. The new variable X is 75, since you are trying to find 75 flights. So all you have to do is plug this in to your calculator. So it's binomial PDF 100, 0.8, 75. To do this, you go on second variable and you scroll down all the way to binomial PDF. Press enter. Enter 100, 0.8, 75. The probability is 0.04387. You want to round to 4 decimal places, so it approximately equals 0.0439. Again, just for reference, you go second, and you go press VARS, then you scroll down to 0, which is binomial PDF. So that's your formula that you have to use. Okay, so this is a probability, which is 0.439. They asked, would it be unusual to observe 75 flights? And it would be unusual because 0.00439 is converted into a percentage, which is 439. Great. You want it to be is bigger than 5. The probability of Dad.
Sorry, go ahead.